Hello and welcome. Today I'm going to show you how to build an Excel VBA application the right way. Now often when you build an Excel VBA application, what tends to happen is you can feel overwhelmed with all the different tasks to do. So you might often think, where should I start? How should I structure it? How should I put it all together? And often you can feel overwhelmed by all the different things that you have to do. And maybe when you're writing the code, you'll end up having lots of errors. And then if you try and change the code, you may run into problems trying to change it in one place and it breaks in somewhere else. So what I'm going to show you today is how to structure an application the correct way, and this will make it very difficult for errors to exist in your code, and it'll also make it very easy for you to update your code in the future. I'm going to show you lots of small little tips and tricks that are used by professional programmers, and these are very easy to implement in your code. Now the application we're going to do today is we're going to take the data that we have here, and we're going to go through this data. We're going to sum it by company, and any company that has an amount greater than 150,000, we're going to subtract 10%. And then we'll write out the report to columns F and G. So let's create the report, and you can see the result that we got. So this is a very simple application, and we could even do it without using VBA, but the whole point is to have a simple application so we can demonstrate the different techniques that we use when we're building applications. So let's go ahead and build this application from scratch. So let's close this version and we'll get started with the version that we have that doesn't have the code. So as always, we press Alt F11 to enter the VBA editor. Now we've got two subs here, and I'll just explain them a little bit later. So these are just two utility subs that I use everywhere. Now the first thing we want to do when we're here is we want to create a button. And what we want to do with the button is when the button is clicked, it runs our code. Now typically what people do in this situation is they tend to have a sub that does something and then they just assign the button to it. But the problem is it's very messy and it's very difficult later to figure out which macro is attached to which button, and your macros tend to be all over the place. So what we do is we do insert module, and we create a module, and the module is called click events. And what we put in click events is just any sub that's called when a button is clicked. Now we say public sub, and we're going to call this one create report, and then we'll say underscore click. So it's very obvious when we see this sub what it does. So what it does is it runs when a button is clicked. Now we'll put in a message box here. We'll just say create report. And this will just show us that it's working. Now to add a button is quite simple. We just go to the developer tab and we select insert, and then we get our button and we just draw it here. Now it asks us at the start to select which macro you want, but I'm just going to press escape for the moment, just to show you that we can do it at any time. And what we do then is we say create report. So now to assign this button, we right click and we say assign macro. And you can see it's quite easy to figure out the one we want. I mean, there's not many, but you can see underscore click, and it makes it obvious that this is something that we're looking for. So now we press create report, and you can see it brought us up the message box with create report. So this is the first lesson, is to put all our click events in one module, group them all together. Now the second thing that we want to do is we don't want to put any actual code in our click events. Instead, we call a different sub or a different function. And the reason for this is that it gives us separation from our button clicks to what the actual code. So if in the future we decided that we want the code to run on a worksheet change event or some other event, it means it's very easy to update our code. So we say call create report. Now obviously I haven't created this yet, and so I'll do an insert and then create a new module. Now we'll call this module report because it's our main one, and we can call it what we want, but it's always good to have good names in our modules and to group the similar subs together, so groups that are related or subs that are related. So that's why in modutils I have utility subs here, and these are subs that we can use in every application. So we'll do a public sub and create report. And this is the one that we're going to call from our click events. So we're going to call create report, and that will get here. So one very useful thing in VBA is the debug print command. So debug print prints to the immediate window. Now the immediate window, you can get it from Alt View, and that's immediate window, or you can just press Control G. Now it normally is down here like this, but if you double click on it, you can pop it out and adjust it as you want. Now when we run debug print, we can just put the name. So I'm just going to put the name here. And when we run this sub, so we can run by pressing F5, or we can go to the run menu. You can see that it wrote out create report here. So if we want to see from our button that it's working correctly, we can go here and just click on our button and then check the immediate window. So we click here and you can see that it wrote out create report. Now we can do many different things with debug print. We can print out variables as well. So for example, we can say dim name as a string. I would say name equals John. And if we run this code, then it'll print out the value of the variable. And we can also do calculations. So we could do 5 multiplied by 6. And so being able to do all this is very useful indeed, as we'll see later. Now we want to do 3 things in our application, and these are as follows. We want to read the data. So we want to get the data into a way, we want to read all the data from the worksheet. Then we want to, with that data, with the overall values of amount, we want to check for the values greater than 150,000 and apply a discount if it exists. And then after that, we want to write out our data. So 3 simple tasks really. And what we'll do here is we'll put in a comment. So we'll say read data, apply discount, and finally we're going to write the data. So far I haven't done anything that exciting, but we're building a nice structure, and as we keep going you'll see how we're not getting overwhelmed. We're just putting a nice structure together, and what we're really doing is we're tackling every task that we have in small chunks. So the first thing we're going to do is we're going to put in all our subs. So we're going to have call read data. We're going to have call apply discount. Now these subs do not exist at this time. I'm going to create them in a moment. And we're going to call write data. Now the call keyword is optional. You don't need to use it, but I like to use it because I think it just makes the code a bit more readable, but it's optional. So we'll control and paste down here, and then I'm just going to take this, I'm going to do Control H, and I'm going to replace that with sub. And we're going to make these private subs because they're not going to be called from outside this module. So that's why we say they're private. So we do replace all here, and we've got our sub. So we just have to hit enter on each line and it'll automatically add the end sub. Oh, it did it already here. So what we're going to do now is we're going to do our debug print line again. We're going to do debug print, and we're going to do the name of each sub. So this kind of shows us the flow of our actual application. So we apply discount here, and we apply write data here. So you see we're building up a nice but simple structure. So if we go to our button now, which is how we're going to write, or how we're going to run our application anyway, we use create report, and if we Alt F11 and go back, you can see that it wrote out read data, apply discount, write data. So we haven't written any code to really do anything yet, but yet we're building up a nice structure, and we're getting it in our head how we're going to tackle this problem. Now the first thing we want to do in actual terms of doing something useful is reading the data. So we want to read the data, and our question is, how do we store the data? So what we use to store the data is what we call a dictionary. So a dictionary structure, if you're not familiar, is basically a key value pair. So when we have an array would look something like this. We might have apple, orange, and say pair like this. and that would be how we'd store it in an array. Let me just make that a bit bigger. But if we're dealing with a dictionary, our dictionary is what we call a key value pair. So it's like a real world dictionary. Everything has a unique value in a real world dictionary. So a word is unique, and you don't read through the dictionary to find a word. You go straight to the word. So what we have a key pair. So we could have fruit, and we could have the actual values or volumes or something that has to do with fruit. And we store them like this. So why this is useful is because when we read the first item, so I'm going to create some just really simple sample data here. So we'll say apple, orange, and we'll say apple again. So very simple data, and let's say our dictionary is empty. And apple is 5, we'll say orange 2, and we'll say apple 9. Now we read through the data, we get apple 5. So it's not in the dictionary, so we add it to the dictionary and we add the value. So now we read our next piece of data, and that's orange. It doesn't exist in our dictionary, so we add it and we add the value. And then we read the next bit and we say, oh, does apple exist? It does exist, so we add it to the current value of apple. So if we keep going like this, we're going to get a unique fruit, and we're going to get the sum of the data for that fruit. So that's why we're using the dictionary. Now, if you want to know more about the dictionary, you can check it on my website, excelmacromastery.com. It has a big article on the dictionary, and I've also got lots of videos on my YouTube channel. Again, it's Excel Macro Mastery, and they're all on the dictionary. So if we go back here, what we've decided is that we're going to get a dictionary. So how this works is we declare a dictionary variable. So we declare it as dictionary. Now you see dictionary doesn't exist. Now if we do a debug compile, it tells us that dictionary does not exist. What this means is that we've got to go to Tools, References, and we've got to find Microsoft Scripting Runtime. So this is an external library, and this allows us to use an external library in our VBA code. Now we do a debug compile, and there's no errors. So let me explain how debug compile works, because it's a very powerful tool. So if we write code, and for example, let me turn on my syntax check. So I normally don't have it on because it's normally not needed once you're kind of familiar with the errors that can happen. So imagine I declare a variable like this, and I'll get an error, and it says compile error, which is a bit kind of confusing, but it's actually a syntax error, and it says expected end of statement. Now, the syntax errors happen on one line, whereas compile errors, the lines could be okay, but maybe we're missing something on another line. So it's basically checking through the project. So if I do for I equals 1 to 10, and if I do a debug compile, this will tell me my variable isn't defined. So I add this variable, dim_i as long, and then I do another debug compile, and now it tells me the for loop exists, but it doesn't have a next. And now I do a debug compile again, and nothing happens. Now, in the olden days when computers were a bit slow, this bar here is actually a progress bar, but because it happens so quickly and because our application is so small, it's basically like nothing happens. But if you did this on, say you had like 20,000 lines of code, you'd actually see something happening here when you do a debug compile. But if you go back to debug and it's grayed out, it means it found no errors the last time. Now, why debug compile is very useful is because it checks through all our code. So all the code in this workbook will be checked. And we should always do a debug compile before we run our code, because we can have errors in it that we don't come across sometimes when we run the code. And then we may leave our code thinking it's fine where we actually have errors. So debug compile assures us that we don't have any compile errors. So let's go back to what we were doing here. So we declared our dictionary, and I want the dictionary to be created in read data. So I'm going to say set dictionary equals read data. Now, because I'm returning something from read data is actually a function, because functions can return, but subs can't. And we're going to call it as dictionary. We're going to return a dictionary. Now, one thing I like to do here is when I'm dealing with, say, creating a dictionary and we're going to return it, that's what we know is going to happen here. We know we're going to create a dictionary. So let's do that first. We want to create a dictionary. So we say as new dictionary, because this will create a new dictionary structure. We're going to do stuff with the dictionary, and we know at the end we're going to return the dictionary. So let's get this out of the way and get this working at the beginning. Now this is working. You can use debug compile anytime. It's super fast, and at least we know when we get to the next bit of code that everything we've done so far is okay. So we just do a quick debug compile. There's no errors, so we're good to go. So if you want a shortcut key for debug compile, it's just Alt-D enter. Alt-D enter or Alt-D L, whatever is most convenient. So now what we want to do next is we want to read through our data. So we want to read through all the data here. And we want to do it line by line. So how do we do it? Well, the first thing we want to do is get the range. So we do dim rg as range, and then we set the range equal to, so we get the sheet name. Now, if you look in the top left up here, you'll see sh data, and then in parentheses data. Now the value in parentheses is the actual worksheet name, the one you'll see on the tab, and the actual sheet data is what we call the code name. Now we can set the code name in the properties down here, so I'll just pop that out. So this is the code name, and this is the actual worksheet name. Now the reason the code name is so useful is because if the user changes the name of the worksheet, our code will still work fine. So it's kind of like a customer ID code. The customer can change their name or address, but their ID still relates to their same account. So we use the sheet data, we can access it directly, and we say list objects, because we're accessing a table. So a table is list objects in VBA. So if we click on this table and we go to table design, you can see the table name is table 2. So I'm going to change it to table data just to give it a nicer name. And so we can access this like that. And so that gives us access to a table. And when we have the table, we basically want the data body range. So in other words, we want the data, but not the header and not the totals row if there is one. So this is actually very, very useful. So once we get the range, we always read through the range like this. We say dim I is long, and we say for range, for I equals 1 to range.rows.count. And we finish obviously with a next I. Now how we access the cells is range cells, and I is the current one. So it's the current cell that we're going through in the loop. And then we use whatever the column that we want. So we want to access column B and C. So that's column 2. Now this is one thing people often do wrong in VBA. I think it's one of the biggest problems for writing readable code. And that is they use this kind of syntax all the time. Now it's fine to read from this, but if we keep referencing and keep using this in our code, not only is it slow, but it makes the code unreadable. So what I do instead is I do something like company as string, and then I'll do amount as double. So I'm creating a variable, and then I'll say company, and the company equals this, and then I'll say amount equals. So in the future, when I'm referencing these values, I'm not currently reading all the time from the worksheet. Instead, I'm just reading from a much more readable variable name, and as well it's quicker. Now we want to add it to the dictionary, and the beauty of the dictionary is we can say dictionary company equals what's currently in the value plus the amount. So dictionary company will return us the current company. That's the key, and it adds the amount to that, and then we place all of this, the result of that, back in company. Now there's one real beauty to this line, and the beauty is that if the item doesn't exist, so if we come across the company that doesn't exist currently, it will automatically add it with this line. So we don't need to do if it exists. We don't need a check like that. This actually does it all for us. So this is a real useful attribute of the dictionary. So this will fill up the dictionary, and then what happens is we send it back. So let's do a debug compile. And then let's run the code and see what happens. So we run the code. So nothing's going to happen because obviously we haven't, we're not writing it out anywhere. Now we can put a breakpoint and check the dictionary if we want, but a much nicer way to do it is to create a sub called print dictionary. And what this sub does is it takes the dictionary and it'll just print it out to the immediate window. Now, of course, we haven't created it yet. So let's create it here. And it's very easy to read through a dictionary. We say dim key as variant. And then we just say for each key in the dictionary. And then we'll just print out the key and we'll print out the value at the key. We do a debug compile and let's go back, and now we'll bring up our immediate window and let's run the code. We go back to the immediate window. You can see that it's given us the values. So one thing that we should try always when we're doing stuff like this, we've just done the read data, but we should make sure that the read data is working okay. So that's the total for Venus stores. So let's add a totals row here, and then let's just filter by Venus stores. And you can see that the values match. So we know that this one is correct. Now, normally if you're building an application, we check a few more, and you'd always check the first company and the last company, because this is typically where errors are most likely to occur, that we miss the first row or that we'd miss the last row. So now that we know that that's okay, we can move on to the next step. So you might be wondering why we broke it down into different subs. So we've got a read data, we've got apply discount, and we've got write data. So what this means is that we're separating our different parts of the application. So read data is typically what we call the data layer. Apply discount is what we would call the business layer or the business logic. And write data is the presentation layer. And the reason we separate them is that suppose in the future we decided to read the data, and the data that we're reading is going to come from a database, or maybe it's coming from a file or just a different format. We can create another sub, or we can rewrite this one, whatever we want. And as long as we pass the dictionary in the same format, we don't have to change any of the future code. So our code to write the data doesn't know anything about our code to read the data. It just knows that it's getting the data in the correct format. And the same with apply discount. So this makes our code very useful indeed and makes it very flexible. And in fact, if we even decided we're creating a second report and we're going to get the data from a different place, we can just call write data, and we could have called apply discount and then just have a different read data sub. So again, we're not duplicating code unnecessarily. So far we know that our code works, and this is very useful because we've done a debug compile, so we know there's no compile errors in it. We've checked the output of the read data and we know that it's correct. Now what happens with a lot of people is they'll write everything. So they'll write the read data, make the change of the data, and then write it out. And then it's difficult if there's an error to know where the problem is. But we can see very easily if there's a problem. Now if later down the line there's a problem, we can use call print dictionary again to check the data. Now I'm going to put it after this, so we're going to call it again. Now one thing we looked at was the utils here, and we've got two things you can see, two subs. Now we do a turn off and a turn on. So the turn off turns off things like calculation, display status bar, and screen updating because they make the code run faster. Now the other thing is the calculations can cause problems as well if it's doing calculations as you're running code. Now the other thing that we turn off is enable events. So what this means is that suppose, for example, code changes and we've got a worksheet event and then that runs code. What can happen is that it can start an infinite loop. We might change a value, then the value kicks something else off, and that changes the sheet again, that runs the worksheet event, and it keeps happening until we get what's called a Stack Overflow, because we keep running the same function, and Excel basically crashes. So anytime we're running Excel code, it's good to turn off events. Now, how we do it is we basically just call turn off and then we call turn on. Now let me show you how to do it. We say call turn off, and call turn on. Now the speed wouldn't be noticeable in a small application like this, but you definitely notice it on bigger ones. We do a debug compile and all is good. Now one thing just to keep in mind here, often when we're running our code, what happens is the code crashes or we stop debugging it and we forget to finish it. So turn on doesn't get called and now everything is turned off, like our events and everything. So if that happens, we can simply go here, click in turn on and press F5 or run the code and it'll turn everything on again. Now the next thing we want to do is apply the discount. So we pass the dictionary here. And this is the same as the way we pass it to print dictionary. Now print dictionary is quite useful here because we're going to be doing something similar with apply discount. We're going to be reading through the dictionary. So we might as well just take this code here. And we go down here and we'll just paste it. So this should be dict as dictionary. Now let me just go back to the print dictionary for 1 second. So I just have dictionary here. That should actually, if we don't declare it, it'll still work, but it's better to always set the type. So then if we pass in the wrong item, it will actually tell us that we've made a mistake. So apply discount, we're going to read through every item in the dictionary. And we're going to say if the value, so if the value at the key is greater than 150,000, what we want to do, so we've got an error there. So what we want to do is we want to say that dictionary, that value equals what it currently is. I want to say multiplied by 0.9. So in other words, we're removing 10%. And of course, we want to put the end if. Now, if we don't do the end if and do a debug compile, it tells us next without for. Now, the reason that it got mixed up there is because it does the for loop. It goes into the if statement, and it's confused because there's no end if. So it expects that there should be an end if before the next. So if we put an end if here, do a debug compile, and you can see the code worked. So far, debug compile, as I keep saying, we know the code beforehand works. We know debug compile works. Often when we run the code, we might get a different error, but at least if it runs, even though we're not seeing anything, we know that there's a 90% chance, 80 to 90% chance that it's working fine anyway. So every little step that we test and know that our code is working helps make us more sure that our code doesn't have errors. Now the opposite of this is when you write like a whole batch of code and then you go to run the code. You've no idea how many errors that you have. You've no idea how many compile errors. You've no idea that if you fix one error, it's going to break something else. We've taken this in compartments with read data, got this all working, got it compiling, tested the output. We know that this is fine. Always possible there's errors in it, but it's very hard for them to exist using the techniques that we've been using. Now we're going to check, and so I'm just going to delete this again. I'm just going to comment out that write data thing as well, so we're not confused. And let's run it again, and just so we can get all the data on its own. And the data you can see we got here. Now, is the data correct? It looks different, so it's applied something. So I'm going to, again, filter the Venus company. And we'll paste out our result here. So we're looking for 407. So if I do equals this value, multiplied by 0.9, it should give us the same result. And you can see that it does. So we summed all of Venus's amounts. We multiplied it by 0.9. So we got 90%, or we got 90% of what it should be, took off 10%. And that's the result. So we're happy enough that what we got is good. Now there's one thing here, and it's kind of a personal thing that you can do if you want. We pass in the dictionary here, and the dictionary is getting passed by ref. It doesn't matter how it's getting passed actually. That's just really to do with the variable. But the point is that if we change dictionary within apply discount, it gets changed. But the problem is it's not obvious that it gets changed. You know, you might think, because like in print dictionary, we pass it in and it's not getting changed. So you can't really tell that one is changed and one isn't. So what I like to do is I like to say set dictionary equals. So we're going to pass back the dictionary. and we say as dictionary here, and this has to be a function because we're passing back, so we can only pass back in a function. And then we say set apply discount equals dictionary. So we're actually passing back the dictionary explicitly, so this makes it obvious that the dictionary is changing. Now you might think, is this a big overhead? We're copying the dictionary back, but actually it's not, because the way VBA works under the hood is that we've got one dictionary in memory, and when we pass it into a sub or a function and we return it from a function, it's actually just passing the address around. Now we don't have to worry about that. VBA takes care of all that for us. But the point is that there's no overhead because it's really just passing back a variable that contains the address. But the important thing is it makes it very clear here. Read data is returning a dictionary. We're passing in a dictionary and we're getting back a dictionary. So this is changing something, and print dictionary is taking a dictionary. But because it's not returning anything, we can conclude that it's not changing it. So that's why I like to use that, even though it's strictly speaking not necessary. So everything so far is working okay. As we've seen, we've checked the data, we don't have errors in our code, and it's applied the discount. So everything seems good. So now we're in a position to write out the data. And again, to write out the data, we're going to be reading from the dictionary, but we're not going to use a loop this time. We're going to do something a bit nicer. So again, we just put dictionary as dictionary. And what we want to do here now at this point, first of all, is we want to clear all the data. So let me just get rid of the filter. So for example, let's just put in kind of just random data here. So I just want to show you to clear it. So we take the sheet. We want to get range. Now the range we want to get is F1. And we want to clear the contents. But the first thing is we don't want to clear the header. We don't want to wipe out the header. So we do offset 1. And offset 1 will move it down 1. But what we do first is we do the current region. The current region is the same as pressing Control Shift, is Control asterisk. So Control Shift and 8 will give us the current region. So when we press the current region, it gives us all the adjacent data. So it's very useful rather than having to kind of figure out what the range is. It gives us all the adjacent data. And if the data is in a nice format, it's very, very useful. So as I said, we get the current region, but we don't want to include the header. So we offset 1. So what offset does is, offset will take this and it will move it down 1. So it'll move the whole range down 1. Now we're including a blank row, but it doesn't matter because we're just clearing the data anyway. And then we just simply say clear contents. So again, debug compile. We do an all to F11. And then we do create report. You can see that it deleted all the data, but it didn't delete the header. So it's very important to delete data like this because two things. First of all, you're going to be doing it a lot when you're testing your application, and it's just wasting your time having to go through and delete data, especially if there's a lot of it. And the second thing is, when you run your code, you want to make sure that there isn't some data left over. So for example, imagine we had data on this row here, and we ended up writing data to these first rows here. And then when we look at our data, we're thinking, this is wrong. It doesn't make any sense. How can we have this extra row? But when we wipe the data, we're just making sure that we're not tainting our current data with some legacy data. So now we've cleared our contents, we want to write the data out starting at range F2. So we say value equals, and this will equal dictionary. We can write out the dictionary in one go. So we say dictionary keys. So dictionary keys is an actual array on its own. So we can actually write it out as an array. Now when we run this code, it's not going to write out everything, and you'll see why. It runs out the Venus Doors Company. And the reason is because when we write out to a range, we've got to resize the range to be the right size. So we're going to resize our range. We're going to say column size, and that's going to be dictionary.count. So it's going to be the number of items in the dictionary, the number of columns in our output. We're going to resize the range to the number of items in the dictionary. Let's run the code. You can see that it wrote out all the companies. Now obviously we want to write them vertically rather than horizontally. So we say row size instead. So we're resizing. So rather than resizing across like this, we're going to be resizing down like this. And obviously we need to change our data. So we use worksheet function, transpose. Again, we do a debug compile, Alt F11, create our report, and you can see it wrote out all the companies as we expected. So now we've got all the keys wrote out. It's very easy to write out the values. We basically use the same code again, and we use dictionary items rather than dictionary keys. And we say G2 because we're using column G2. Everything else is the same. So we click create report, and you can see it wrote out all the values as we expected. And so that's our application created. Now just a few points to recap here. I just want you to notice how I've got 4 subs here, and none of the subs really have many lines of code. So this sub, for example, it's only got 1, 2, 3, 4, 5, 6, 7 lines of code. And even the subs down here, and some of these are like declaration lines, they've only got like a handful of lines of code. So when we get small subs like this, it's very easy to test. We could send in a test dictionary into apply discount, and we can test the result of a test dictionary, because all this sub is doing is applying a discount to a dictionary. The same thing with write data. We could give it dummy data and write out the data and just check that the data is correct. So we can isolate any of these subs and we can test them. So again, if there's a problem somewhere, it's very easy for us to isolate each one of these and see where the problem is. So that's how to build an application, and I hope you've got something useful from this. There's lots of tips and tricks that I showed you today. So if you find it a bit overwhelming at first, I'd recommend that you go through the video again and just watch it and just, rather than trying to take everything that I've said, just take a couple of the simple things that I've said and try and apply it to your code. Now, if you can do it in a simple application, first of all, it's a really great idea. And as you go to create more complicated applications, then it's easier to try it once you kind of know it a bit. Okay, thanks very much for watching, and let me know in the comments what you thought about the video.